Jika ditulis persamaan reaksinya adalah sebagai berikut, di mana A adalah bereaksi dan B adalah produk. Jika suatu saat laju reaksi ke kiri sama dengan laju ke kanan, disebut saat setimbang. Secara grafik adalah sebagai berikut.
Okay, in this video we're going to talk about the concept of equilibrium. And we're going to learn something that we never knew about chemical reactions before. It might be kind of interesting to see that we might be carrying a big misconception about chemical equations. In fact, I would go as far as to say we've been living a lie. We've always said that reactants get converted into products, right? Right. But we've never mentioned the fact that as soon as some products are made, they convert back into reactants. We have actually never mentioned the fact that products can turn back into reactants. So reactions are actually reversible. Theoretically, all reactions are reversible, but some are a lot more reversible than others. In fact, some of them, hardly any products, will go back to reactants, and we say that those are essentially not reversible. But in theory, I guess everything is a little bit reversible. So, in summary, reactions go both ways. Here's an example. If you take hydrogen and iodine and react it to make 2 hydrogen iodides. Note the arrow length. The arrow going to the products, this arrow, is really long, and the arrow pointing back towards reactants is really short. What do you think that means? If you guessed that this reaction is not very reversible, you were guessing right. The length of the arrow tells you kind of which way the equilibrium or which way the reaction favors. So the longer arrow here means that it favors making products or going in the forward reaction, going in the forward direction, which is the way we normally think of reactions, right? Now it does have a small arrow pointing to the left, which means that some of these products here are converted into iodine and hydrogen, which were our starting materials, but not a whole bunch of them. That's why we have a small arrow, meaning that reaction doesn't go that direction very well. Here's kind of a graphical interpretation of that. We start out before the reaction, you've got a mixture in this container of hydrogen and iodine, right? Both reactants. 10 seconds later, though, we might see in that same container that some of the hydrogen and iodine have reacted to form product, HI. Right? But there's also a little bit of hydrogen and iodine still left in that container. Not necessarily because it didn't react, but because some of this HI, the product, has went in the reverse direction. It has started reforming the reactants that we started with. Okay? So the concept of reversible reactions means that we'll never completely get 100% of our reactants converted into products in a reversible reaction. What you'll end up with as your product over here is a mixture of reactants and products. And if this reaction goes really well to products, in other words, if it has a big arrow pointing to the right, means it makes lots of products, most of the stuff over here on the products would be actual products. However, if it does have the left, that means you'll get some reactants regenerated back here. So you might end up with a mixture, as in this case. If you let this reaction go for a while, you'll get a mixture of reactants and products. Instead of just what we used to think, we just all get products. But if the reaction is reversible, we might actually end up with a mixture of some reactants and some products. Hopefully, if we're trying to make the product, we'll end up with a lot more products. But we'll talk about how to manipulate the reactions in a little while to make them do what we want them to do. Here's another example. You can see that nitrogen reacts with hydrogen to make 2 moles of ammonia. And look at the arrow lengths again. What does this reaction favor doing? Does it favor going in the forward direction? That means left to right, like we've always written it. Or does it favor going in the reverse direction, which means that products actually break down and regenerate the reactants? Which one does this reaction favor? This one, you might have guessed, is very reversible